Alright, here's our fourth example. We have the absolute value of the quantity 2x minus 3 times absolute value of x plus 1 minus 6 is strictly greater than 8. So again, our first thing is get rid of the absolute value at the far outside, meaning we're going to get the two inequalities. 2x minus 3 times the absolute value of x plus 1 minus 6 is less than negative 8, or 2x minus 3 times the absolute value of x plus 1 minus 6 is greater than 8. Then we're going to add 6 on both sides of each equation, each inequality, and giving us the following. 2x minus 3 times the absolute value of x plus 1 is either less than negative 2 or greater than 14. So now, let's focus on the first inequality. And in order to solve the inequality that has an absolute value and we cannot really simplify these two, let's try to think of the cases. So we're going to set up two cases. Case 1. If everything inside of the absolute value, which is x plus 1 here, is greater than or equal to 0. Case 2, and of course, we need to have the rest of the cases to cover everything, which is x plus 1 has to be strictly less than 0. Let's see what we will get. For case 1, we can rewrite the inequality into x is greater than or equal to negative 1. And remember, this is our condition here. So let's plug it in. Now we get 2x plus. Now we get 2x minus 3 times. Now keep in mind, in case 1, we're saying that x plus 1 is greater than or equal to 0. So by definition of modulus, the absolute value sign is not going to affect the expression itself, since it's already non-negative. So we're just multiplying by x plus 1 here is less than negative 2. And if we simplify it, the left hand side, we get 2x squared minus x minus 3 is less than negative 2, meaning 2x squared minus x minus 1 is less than 0. By factorizing, we now get x is bounded between negative 1/2 to positive 1. Now, go back and check. Since we want x being greater than or equal to negative 1, and our solution here is already satisfying the condition. So we're good. There's nothing that we need to change. Excellent. We checked this one. Second case, we now have x plus 1 is less than 0, meaning x is straightly less than negative 1 as our condition. Then what happens is we get 2x minus 3 times. Since x plus 1 is negative, the absolute value sign is going to give us negative of the expression. We get negative x plus 1 is less than or equal to, is less than negative 2. Then we can just take the product of the two factors and also multiply both sides by negative 1. We get 2x squared minus x minus 3 is, keep in mind, since we're multiplying negative 1 on both sides of the inequality, we also need a flip sign. We now get greater than positive 2. So if we throw back in, we have 2x squared minus x minus 5 is greater than or equal to 0. Now, we can just use the quadratic formula to find out, and I'm going to leave the sign for a moment before we fill in. So we use the quadratic formula, we get 1 plus or minus the square root of 1 squared, which is 1, times 2 times 5 times 4, which is 40. So we get 41 here, all over 4. Since we have two values and we have a plus sign here, we now know that we get the following expression, x is either less than the smaller one, or x is greater than the bigger root. Cool. But now we need to check our conditions. Well, this is clearly greater than 0, it's positive, so this cannot be the case. How about this one? Let's see. Negative square root of 41. That is less than 40. This is smaller than 49, which gives us this is greater than negative 7. So if we divide by 4 on both sides, we get this. And perhaps we need to use some calculations here. And we know that this is bigger, 41 is bigger than 36. So we can see that it is bounded between negative 6 over 4 and negative 7 over 4. And if we add 1 on both sides, on top, we get this. So this is negative 5 over 4. This is negative 6 over 4. Now, keep in mind, negative 5 over 4 is strictly less than negative 1. So this is actually lying inside of our condition. So this answer actually is valid. Cool. We checked this one. So now we already finished. Alright, so after our calculation, we actually get, in case 1, we have these two, and in case 2, there's no solution based on the fact that the left hand side is a square which is not negative plus some positive value, which has to be bigger than 0, but now we want it to be less than 0, meaning that there's no x satisfying this solution here. So last, we also need to check our condition. Since in case 1 we said x has to be greater than or equal to 1, clearly x cannot be less than this amount here, which is negative. Now, for the other one, we know that square root of 137 is bigger than 11, so this value is greater than 12 over 4, which is 3. And of course, that means that it satisfies the condition x is greater than or equal to 1. So we now get this, meaning we finally got all the solutions for each case. So we just need to combine all of them back together. And remember, here, case 1, case 2 here are the union of it, meaning that we're taking one case or another. And here, at the beginning, this is also a union. We're taking one case or another. So we just want x to be in one of the 3 cases, and it'll be done, instead of trying to be satisfying 2 or more cases at the same time. So our answer would be this: x is less than 1 minus radical 41 over 4, or x is bounded between negative 1/2 to 1, or x is greater than 1 plus radical 137 over 4. That's it. So we actually see that this looks very similar to an inequality of a quartic polynomial, or polynomial of degree 4. Suppose there are 4 roots, so we'll end up with cases that looks like this. Okay, and why is this the case? Again, this is because we have the absolute value here that actually will double the amount of solution, and here we'll double it again, so multiply by this, so we have actually 2 here plus 1 giving us 3 solutions. Then we double it again, we should end up with 6 solutions. But once again, we have many things happening at the same time, so we actually will have less roots that are satisfying. Okay. Okay, remember we actually erased one right here, erased one right here, and this one can never give us any solutions. So we actually did end up with 6 different roots, except that 2 of them are actually out of the range. That's why we just ending up with only these solutions here and giving us the final answer. All right, so let's move on to the last one. All right, so here's our last example. This time we have absolute value of 3x minus 1 is strictly less than 2 plus the absolute value of x plus 4. So in this case, we're going to again set up into cases. How many cases do we need? We need 3. We'll see why. So first, I'm going to set up case 1, which says this is less than 0, meaning x is less than negative 4. Okay, then case 2, I'm going to set this to be greater than or equal to 0. But in this case, if this is greater than or equal to 0, we have x is greater than or equal to negative 4. At the same time, it's possible that this is still less than 0, but also greater than 0. So we'll suggest to split it into 2 more cases from here, meaning that now I'm saying this is less than 0. So we get x has to be less than 1/3. Now, of course, finally we need to have the last case where x is greater than or equal to 1/3. So let's double check why we just need 3 cases and not 4. If we notice, in the first case, x is less than negative 4. This is turning into negative, but at the same time, this must also be negative because 3x minus 1, of course, is less than 3x. And if x is negative, 3x is also negative. So this is actually turning into negative because of here. Similarly, if x is greater than or equal to 1/3, this must be positive for sure, again, because x is now positive value. Adding another positive value must giving us positive value. So what happened is, case 1, we now get this is negative, this is also negative. So we have negative 3x minus 1 is less than 2 minus x plus 4. So if we simplify, we get negative x. No, we get negative 3x plus 1 is less than 2 minus x minus 4. So if we move the x on the right hand side, we get a 2x, which is greater than, well, if we read the other way around, we get 1 minus 2, which is negative 1, plus 4, which is 3. So we have 3 is less than 2x, meaning x is now greater than 3/2. So this is what happened in case 1. Of course, we need to check our conditions. What is our condition in case 1? X has to be less than negative 4. But our solution is x is greater than 3/2. It contradicts. Therefore, there's no solution in case 1. Let's move to case 2. Case 2, we get 3x minus 1 is still negative. So we need to multiply by negative 1 here. It's less than 2 plus x plus 4. Again, now x plus 4 is positive because x is greater than or equal to negative 4. Or this term is at least not negative, so there's no change for a sign. Then if we simplify it, we get negative 3x plus 1 is less than x minus 2. So we get 3 is less than 4x, meaning x is greater than 3/4, 3/4. What's that mean? Again, our condition is x has to be less than 1/3, but now we are saying that x is greater than 3/4, which is strictly greater than 1/3. So it is contradictory again, meaning there's no solution either. So hopefully we can get something from the last case. Last case said x is greater than 1/3 or equal to 1/3, meaning that both absolute values are not going to affect the expression itself. So we get 3x minus 1 is equal to 2, not equal, excuse me, let me start over. 3x minus 1 is less than 2 plus x plus 4. So now we can just throw the x to the left hand side and then throw the minus 1 to the right hand side. We get 2x is less than 7, meaning x is less than 7/2. Good. So let's double check. Well, x is less than 7/2, which is fine. Our condition says x is greater than or equal to 1/3. So from the number line, suppose 1/3 is around here, 1 here, 2 here, 3 here, so 7/2, which is 3.5, is around here. With the combination of these two conditions, we're going to take the intersection, meaning that from the condition, we take this part to the right, and then from our calculation, we take everything from here to the left. So the intersection will be this shaded part, meaning our solution will be between positive 1/3 and 7/2. And again, in this case, we're going to include 1/3 but exclude the 7/2. And since we are listing out 3 cases, meaning we just need to take the union of it. As long as x satisfies one of the cases, it is good. So if we combine them together, this is our final solution of the inequality. Well done. Right. So here is the bonus question for you guys. Are these two inequalities the same? We have absolute value of x is less than 1 versus the absolute value of z is less than 1, where the conditions are x is any real numbers, but z is any complex numbers, including non-real numbers. So please leave your comment below if you know the answer, or if you think you know how to do it. And hopefully you enjoyed this video, and of course the last video as well. Then if you enjoy it, please don't forget to like and subscribe my channel so that you can check out my other videos. And that's it. I'll see you guys next time.